We continue with our example using glass beads as a model for the soil, our three-phase porous media. We do this because the soil particles are often too small to see, as are the pores in those soils, particularly in the aggregates. So with our 25 millimeter glass beads, we see that there are large spaces between the large particles. And we see that the spaces get sequentially smaller just as the particles get sequentially smaller. Our previous examples used the volume of the container, 100 cubic centimeters or milliliters, and the volume of water that was added or removed to estimate, or as a measure of, the pore volume, and give us also an indication of the solid volume, and we know the total volume. So in each case, what we did was we added water to the cylinder, determined how much water was left, and then we, to get an idea of what the porosity was among the beads, then we poured the water from the beads back into the graduated cylinder to see what was recovered. In this case, though, at each point, we also weighed those cylinders. So not only did we know a volume, we knew a mass. And this is the point where we're going to use the other side of our diagram down here, because the previous examples all worked here based on the volume of the components, whereas this one works on the basis of the mass. So what are we trying to work for here? We have our table and all the data that we want to capture. So we're going to start with the mass. We know the mass of the solids, and so we can determine the bulk density. The formula for this, we go look for the formula for bulk density, and our formula is the bulk density is the mass of the solids. Now in soil, that's the oven-dried soil mass to a constant weight, divided by the total volume. That's not the volume of the solids, but the total volume of the container. Our units for that are going to be in grams per cubic centimeter, and our precision is going to be 0.01. So 1/100th of a gram per cubic centimeter. We'll do the example for the first one here, and then I will work through the rest of them and put the answers in. But I'll ask you to pause the video at that point and then do the answers yourself, do the calculations yourself, and then check your work. So our first example, we have the mass of the solids here is 142 grams. The total volume of our container was 100 cubic centimeters. So the bulk density is 142.8 grams divided by 100 cubic centimeters, which is equal to 1.428 grams per cubic centimeter. Not sure why things are bumping around there, so I apologize for that if it's messing with your eyes. However, let's go back and look at our precision. Our precision was 0.01 grams per cubic centimeter, so 2 decimal places. This one has 3, so we have to round, 1.43 grams per cubic centimeter. So I've found now my first bulk density is 1.43. I've got my units listed over here. Now it's your turn. Pause the video and do the other 3 bead sizes. Hopefully you got these answers. If you didn't, go back and check your work. And if you have questions, you can always contact me with your questions.